is Role of Energy Storage in Renewable Integration panel discussion. This is to understand the opportunities and challenges faced by the renewable sector and explore role of energy storage for renewable integration in India and the policies needed for the same. For this discussion, if we please can have on stage Mr. Pankaj Batra, Chief Engineer, Regulatory Affairs in CEA, dealing with standards and regulations of CEA, regulations of CERC and SERCs and associated issues. He also handles various policy issues. I'm sorry Dr. P.C. Mathani couldn't join us for the same as he is travelling outside India. Next we have with us Mr. Manish Tiwari, who has joined us in place of Dr. Subir Sen as he had some last minute appointments. Mr. Manish Tiwari, Chief Manager at Power Grid. Professor Dalal Osman, Head of Renewable Energy Department at Hamza Associates. Mr. Madhusudan Khemka, Founder of Regal Power Tech Private Limited and serves as its Managing Director as well. Mr. Khemka has over 2 decades of long and rich experience in all aspects of wind energy converters. And lastly, we have with us Mr. Manu Karan, Head Business Development, Sun Edison. So big round of applause for all our speakers for this session. Mr. Pankaj Batra will be the moderator for this session. Pankaj, if you can please take over.
Good afternoon, everyone. I think we got one person short, so that will try to make up some of the lost time probably. We will. This is a panel discussion, so we would like the views of all the panelists one by one on integration of renewables to the grid, which is an important thing which is happening around the world and it's going to happen in greater measure as we go along. So I think it's one which deals with energy security and reduction of emissions. This is an important agenda items around the globe for countries as a whole. So without wasting too much time, we have 1 hour, I think, right? So we have 1 hour, 45 minutes. Okay. So we've got 4 speakers. So let's say we also have discussions later, or question and answers. So if I request each person to speak for 5 minutes, if that's all right initially, and later it could be. Is that all right? So we'll start from the left hand side, Mr. Manu Karan, Head BD Sun Edison. Please go ahead.
Hi. Hello everybody, and thank you for joining us. I'm probably talk more from the business angle and where I see viability of storage and integration with renewable today in India. So there are 2 major aspects, I think. One is the fact that in India storage is primarily looked up as backup by most consumers, and for the utilities, they're still trying to figure out where it goes. Is it at the consumer end or is it at the generation end? We have tried integrating storage into being primarily a solar company, and recently we got into wind as well. We have tried integrating storage at the consumer end as much as possible, primarily lead acid, and now we are looking into lithium-ion as well as flow battery technology. What we are seeing is today it's still not commercially viable, Because in India, the primary market is intermittent grid. And when I say intermittent grid, it's because the grid is not available for a few hours, 4 to 5 hours maybe. Because the payback times are anywhere between 7 to 9 years for any of the technologies, minimum 7 years, right? And what my consumers tell me is that, hey, I can take a view on 5 years, maybe. You know, I don't know what the state of intermittency will be next year, but I'm willing to bet that all problems are not going to go away in the next 5 years. So I'm willing to take a 5-year view, which means you should give me a product that pays back in like 3.5 years, and then I get at least another year and a half value out of it. Anything beyond that is my guess or your guess. So this is the number one issue. Just looking at it as pure backup, right? So now, off late, we're trying to see if we can add demand charge reduction as one of the value adds to economics of this whole case, and try to add more economics in terms of savings and hence reduce the payback. Then it starts making more sense. The similar market exists in the US, which is basically, if you touch a demand, peak demand, even for a 15-minute interval in a month, you get charged for the entire, that peak load. Trying to shave some of that helps both in payback of the storage at the consumer end and helps, of course, same problem that our gentleman from BSES was saying, which is I don't want to build for spiking capacity. I would rather build for a more steady capacity in terms of transmission line and generation. So from the consumer side, these are the two values that can be added. The third one, of course, the challenge for adding demand charge reduction application is, of course, the availability of data. To do something like that, I probably need a year's data which spans all 4 seasons of what the kilowatt loads are. If you see, usually it's compressor load that causes the spikes, and to understand that we need a year's data to see what is the value that we can really add through demand charge reduction through storage, how much storage is really required. Today the utility has the data, but we are not allowed to tap into the utility meter, rightly so, because otherwise you can tamper with that meter. But then it is not readily available for companies like us that are trying to address this issue. So that's the challenge from adding demand charge reduction to just plain backup to bring storage to the commercial viability. The third aspect is demand response. Demand response is what the utility asks from its peaking plants like gas and hydro. Nothing like battery storage can ever be as instantaneous. However, where does the demand sit? So like the gentleman from BSES was saying that it needs to be in a distributed method and not a centralized gigantic 30 megawatt battery kind of location. It's very hard. In that case, who invests on it is the challenge. If they invest on it, we need to, like many companies like us who are developers are willing to invest on it at a consumer location, but visibility into how much time will it be really used, that becomes a challenge. Financing it is the key issue. Unless you have a steady cash flow or predictable cash flow, that becomes a problem. Yes, it could be used 10 times in a year, 20 times in a year, maybe 100 times in a year, you just don't know. Demand response, that's the problem. The other aspect is also trying to ensure or mandate that renewable energy comes with a minimum of X hours of storage. So in case of variability, you're able to give a predictable solution. In that angle, we are trying to work with Dr. Kemka's company to see how wind and solar can be combined together to increase. If you think about it, DC generation from wind and DC generation from solar can be fed to the same inverter. So if you take a megawatt of solar and a megawatt of wind, you can combine it into 1 megawatt AC as long as you pick the right location and you have complementary generation pattern. That is one location where you can increase the utilization factor of renewables being connected to the grid. No matter how well you pick the site, you're going to have some amount of curtailment because both might peak at the same time, generation. Can we add that to storage? And even if, combining a megawatt of AC power, can I even give 250 kilowatts of firm power or schedulable power? That can be one of the avenues that can be explored as well. It's a little further down there in terms of research, I would say, but that can also be pretty close to commercialization. In my opinion, it's about 2 years away from commercialization, finding the right kind of battery technology. So with that, I probably will hand over the mic to Dr. Kim Gai. Thank you.
Thank you. I'll request Mr. Madhusudan Kekka, MD of Region Power Tech and Chairperson of IWTMA, Indian Wind Turbine Manufacturers Association.
Good evening, friends. A small correction for my friend. I'm not doctor. I don't know whether in this lifetime I'll be able to get a doctorate degree, but thanks for the compliments. We at Region Power Tech have a unique position. We look forward to a viable storage solution very, very eagerly. The reason for that is, as Manu was trying to explain, we have technology where we have AC-DC AC conversion because we are a wind turbine manufacturing company. We provide turnkey solutions to our clients, and most of them are large IPP clients. So we have AC-DC AC conversion in this process because we use permanent magnet generators with variable speed, design. So we have this DC to AC conversion finally, and we have better integration possible between solar and wind. And that is where we are trying to work very hard with the wind solar hybrid solutions. We have offered some solutions to a lot of our clients. They are all excited. And what we are waiting for is only some policy guidelines on the tariff on a hybrid system. And that is where even Mr. Batra will be able to help us going forward after this discussion today. But I believe as an individual and also as chairman of IWTMA, Indian Wind Turbine Manufacturers Association, and vice chairman of IVR, which was launched by Honorable Minister yesterday, Indian Wind Energy Alliance. We believe that slowly renewable will change the dependence on conventional power sources. When we talk slowly, it is not far away. Maybe 5 years down the line, we will start feeling it. 10 years down the line, we will become more dependent on renewables, and maybe 20 years down the line, it will be, our dependence on renewable will be much more higher than conventional power. And without storage, it is not possible. Because we do not have control in input. We do not know when we will generate. I'll give you one typical example. Like many states in India, we have, when we talk about hybrid solution, how it makes sense. When we have, states like Rajasthan, Gujarat, Madhya Pradesh, or this northeast part of India, northwest part of India, we have higher wind velocities generally during late evenings, early mornings, and in the night. And we all know that we have much more, energy from photovoltaic or solar systems during the day. So we are able to give a much more smoother power curve in 24 hours as compared to standalone wind or standalone solar. And we find that in between that gaps or the flips, that is where storage can play a very, very important role. See, today as industry we are facing a huge challenge of forecasting of wind, scheduling and forecasting of wind. We are trying to use all possible mechanisms, we are trying to use all technologies available globally, but still we are not able to give satisfactory response to the regulatory authorities on this. So, one wind solar hybrid with storage can give much more predictable power curves. Number two, see, if we have to improve our dependence on renewables, this uncertainty factor we have to remove from that. And that can happen only through some viable storage solutions. I come from Tamil Nadu, and we have huge power cut problems in Tamil Nadu. Mainly industrial units are suffering or struggling to meet their power requirements. And on an average, they spend anywhere between 18 to 20 rupees per kilowatt hour when they use all sorts of solutions possible using different diesel or other solutions. So, Mr. Bansal was talking before this session started from BSCS. I think a simple mechanism where you have energy available or electricity available at cheaper cost, you have a battery storage combined with renewable energy, and then we use that power when it is required during power cuts. I think still we can find a very viable commercial proposition than looking at storage in isolation and comparing it with conventional energy cost, what we are talking. To start with, battery storage will fill the gap between the expensive storage what we are using, expensive electricity what we are using, and power cuts. But slowly going forward, when the costs come down, like flow batteries and many other new things are happening globally, so slowly it will come down, and I am sure when renewables take over going forward, it will be not one renewable, it will not be even hybrid of only renewables, it will be hybrid of renewables with storage. That only will find a solution, and we are of very high belief that this is going to be the solution for energy in the country, not only country, maybe globally, and nothing else. There could be anything new which we are talking in terms of having energy source, but storage will still play a big role. This is, say, like 10 years back, solar looked like a very unviable proposition. And even in this country, the first few contracts were signed at 18 rupees per kilowatt hour. Today, storage is marching towards grid parity, and if we remove solar is marching towards grid parity, and if we remove all the subsidies which are given to conventional sector, maybe it has already a grid parity. When there is a fixed tariff for number of years, anywhere between 10 to 20 years in case of solar or wind, and we have variable tariff for the conventional power, and the way we look at the coal sector today, we believe that the renewable is already viable. We only have to remove the uncertainty factor, and that you can remove it with the storage solution. Thank you.
Thank you. I now request Mr. Manish Tiwari, Chief Manager Corporate. He is looking after the pilot project, Smart Grid pilot project in Puducherry. So let's have his thoughts.
CS are working hard since a long time for this conference, and it is now live here. I congratulate them. Green energy, due to various green energy benefits and towards energy security, Government of India and other state governments are also looking for more renewable energy penetration in India. Presently it is around 33 gigawatt, which is roughly 12% of the capacity in capacity terms and 6% in energy terms. But in this 12th plan itself, around 33 gigawatt addition is planned. And we expect that by 2017 it would be around 55 gigawatt. By 22 it would be around 98 gigawatt. And by 2030 it would be 235 gigawatt. And in 2030 it would be around 30% in capacity terms and 16% in energy terms. This is a big figure. And we all know that renewable energy is intermittent and variable. This impacts our grid also. I am from power grid, and we are planning system for interstate transmission, and we are facing this challenge. We have found that even at the state level there is a wide variation in renewable energy output. It is going up to 50%. At plant level, definitely it is ranging from 0 to 100%. But even in state level, renewable energy is going to 50% of the peak. And that is in Gujarat and Tamil Nadu. This wide variation is to be checked. Generally, renewable energy impacts grid in many ways. Power plant, change in power plant mix is the way. Generally, traditionally, we are having some base load plants and some peak load plants. But addition of renewable energy is adding one more type of plant which are intermittent and variable. Second, variation is very fast. That's why frequency for tight frequency regulation, various ramping methods are required. Ramp range and rates are also changing. Because see, in evening, when there is sunset and peak load is coming, then suddenly solar power is reducing. So then you have to catch load also and tackle reducing solar power also. In night, when load is coming down, in off-peak hours, wind energy is getting high. So for such a high ramp rate, we have to be prepared. In the morning, Sonisa was saying that around 350 megawatt per minute is ramp rate. In future, we may have to prepare for more than that. Then complexity in scheduling. Renewable energy forecasting is very complicated. It depends on various factors. And in India, we are doing some pilot projects. Definitely in worldwide they are also forecasting, and if renewable energy penetration is high in India, then we have to have forecasting facility also, and scheduling should be exact. Then system planning. Renewable energy generation takes a very short time in project implementation, generally 18 months. But transmission planning takes around 36 months. So we have to plan transmission system for renewable pockets early. That is the challenge we have to face. Generally, when renewable energy penetration increases, we have to take series of measures. Grid integration, for grid integration, transmission strengthening is one measure, which is done in early stage of renewable when penetration is low. But when penetration increases, we have to go for flexible generation, flexible load also, time of use tariff may be implemented. New loads also can be added like AC, air conditioning, and electric vehicle that can be introduced. And if renewable energy, more renewable energy is integrated, then definitely we have to go for energy storage options also. In India, and Power Grid is also doing various measures to tackle such problem. We have submitted report on green energy corridors to government, and implementation on that report is already in progress. And apart from it, pilot project on pilot project on forecasting is in progress in Gujarat, where we have started forecasting for wind as well as solar. And for REMC also we have proposed in green energy corridors. In India, generally renewable energy is located in few pockets across the country, mainly in 7 states: Gujarat, Tamil Nadu, Andhra, Karnataka, Maharashtra, J&K and Himachal. Rajasthan is also there. Then we should have, generally these renewable energy plants are less in capacity, 50 megawatt, 100 megawatt or so. And in our grid there are many plants which are of the order of 4,000 megawatt. In the morning, Sonisa was saying that mindset of grid operator is for larger plants. Different skill sets are required for renewable energy. That's why we have proposed REMCs in Green Energy Corridor report, in which in 7 states REMCs will be set up, and these REMC will tackle renewable energy in that area as a whole, and they will communicate with existing RLDCs and NLDCs for dispatch of renewable energy. The work is on that REMC is also in progress. It is in the stage of final discussions, and implementation will soon happen. Then energy storage also we are exploring option, and even MNRE has come up with UI for that. Power has already tendered, issued RFP for energy storage system. We are implementing our battery energy storage system at Pondicherry, and it is since there are many technologies and grid scale battery energy storage system is there to be implemented in India. We have opted for 3 different categories. One is advanced lead acid, second is lithium-ion family, and third is for sodium nickel chloride, NIMH flow batteries. And already bids have been opened and it is under evaluation. And we expect that by January last or February start, we will award for that packages. And after that, evaluation will be done by Power Grid for various parameters, and then we can come up with more plans for energy storage in India. There are some regulatory aspects also. Energy storage works as a generator and as a load also. In present conditions, regulations are there for generators and for consumer sides, but there is no specific regulation for energy storage which acts as a generator, as a load also. Then how it is to be absorbed in grid, whether some energy storage obligation should be there or subsidies to be provided. So various measures are to be taken by Government of India, and these are in different stages of implementation, and already task force has been created for energy storage in MNRE. We expect that very soon we'll have policy for energy storage, and large scale implementation will take place. Thank you.
Lastly, I request Professor Rana Osman, Vice President of World Wind Energy Association, to share his thoughts.
Good afternoon, distinguished panel and speakers. It's my pleasure to speak at the end of. It's very hard to talk about all of these presentations, but I'd like to make some change to look at it from different angles. We'd like to decarbonize our life, our system, so that global warming and all the stories we are afraid of. Then we have renewable resources. We'd like to have them in our life, not on our grid. Because on our grid, then I'm going to have the electrical track. I'm going to touch the symphony of renewable, which is hydro, wind, solar, geo, and bio. In a normal community, you can have bio from waste and waste from plants and forests and so on. And then you can have your wind turbine, whether they are inland or high altitude, 3 kilometers in the sky, and then with optical fiber you're getting your energy. And if your wind is not that normal, then you can go offshore. There is now floating wind turbine. So this is if you like to tap nature and to get your wind, either from high altitude, floating HAT wind turbine, 3,000 meters in the sky, rotating, and then you collect your energy, or in water. And then you go for solar. Solar, I should go in PV or CPV, concentrated PV. And now we have floating PV, some wind, some water lakes in Australia and France, there are floating PV. And with floating PV, there is a beauty. If you look to some hot country like Egypt, my country, and Lake Nasser, and there is high temperature, then such lakes, if discovered by floating PV, then it can be cooled by water evaporation, and then you have higher efficiency. There is no degradation of your power output due to temperature. And then you are saving water from being evaporated, and then you have your electricity, which can be by electrolyzed to hydrogen, and you store hydrogen or make methane out of it, and then you have CH4. Or we go for the other track of solar thermal, and then I'm going to make it so to have the saving in thermal way. And this was, we were talking always, this track this conference is concentrated on electrical batteries and the grids, and this is one of the tracks of energy. But we have not only electrical batteries, we have thermal batteries. On every roof, in some cities you have 10 million electrical heaters. Every one is about 2 kilowatt. Any cloud, you can have such sudden load. Energy community should go for energy saving before going to energy, renewable energy, and then saving energy. The first land of defense is replacing all electrical water heaters by solar, and then have your solar storage. This is solar thermal battery. And then in a city like Delhi, or like my city, we have 8 million electrical air conditioner. So in July and August, power plant dispatching center, you have ramp of huge gigawatt for a few hours, and this cause the blackouts. This can be shaved, not to generate electricity to meet these peak hours, but by having for that other type of batteries, which is not electrical battery. I talked about the thermal battery, but ice batteries. Ice batteries and ice tanks. And the gentleman from civil system was talking how they can produce, which is already 20 years in the States, ice tanks and industry and an application. And then there is the legislation how to integrate them with the buildings. New buildings, new community for our young boys and girls to marry and to spread outside of the congested cities. Then she'd go there and have off-grid systems. It's another track. Then there is nothing called integrated. Let us integrate to nature. Let us solarize our system, our air conditioner, our water heater, and our grid. Save electricity, if your load is electricity. We don't ventilators and air conditioning, we can have them on other ways, except having running vapor compression system and split unit. There is absorption cooling, which can be run by natural gas or by thermal energy. I worked in Miyazaki, Japan for many years in absorption system to have 0% electricity for a solar house which is running to get your hot water, and then you get your air conditioning from absorption system, and then you are cooling your ice. I can make my cooling and I can make my ice and store them in the garden, and I have my hot water tank and I have my chill or my ice bank tank, and then I pass some air with photovoltaic system, and then I have enjoy the cool air. So this is a thermal battery. So then, in addition to solar and wind, we have wind. This is the sources around us. And in addition to the electrical battery, I have the thermal battery and the ice batteries. This is from the point of energy conversion before going to storage. And then you go to storage, you have distributed storage and bulk storage. Many community now to go for solar energy, I go for PV with the all size of batteries, and then I can go for CSP and with molten tank storage. Now in the state of the art, there is 50 megawatt storage for 10 hours in solar in CSP farms, and I have a tank full of sun. This is my battery. The scale now has shown with molten salt material and different materials to be used, and I am running my solar battery or my electrical tank full of sun at 500 or 600 degrees centigrade. It's another area. Then I can find a single tank where I have 800 megawatt hour. 8 hour by 50, 400 megawatt hour. And in this is the case, in the solar system, I have two fields of mirrors. One for daytime, which I run my power plant, where now already all mini solar power plants are dispatchable. They work 24 hours. One for day operation and the other one to charge my tank, and then I have it for night operation. So this is another area of storage. So I am trying to diversify the portfolio, what type of energy, wind and solar or bio, or hydro if you like. And then in the system, I have air conditioning, and I have water heating, and then I have water desalination, and then I have water pumping. Many farmers need to look for water pumping. I don't like to follow the electrical track. I can pump when I have my solar and having the gravitational power, and I have my tank on the level, because in many places water is 1,000 meter deep. And this is a huge problem. It's very well known, the reputation of Indian pumps, but not with solar and with wind. This should be combined, this one. And then desalination. Many desalination systems, RO system, all the Gulf are running a cogeneration power plant, and then you have your, give me 5 kilowatt hour, I desalinate water for you. If it is 40,000 particles per million, like in the Indian Ocean and Red Sea and so on, or it is brackish. Now in the state of the art, there is 50 megawatt storage for 10 hours in solar in CCP farms, and I have a tank full of sun. This is my battery. The scale now has shown with molten salt material and different materials to be used, and I am running my solar battery or my electrical tank full of sun at 500 or 600 degrees centigrade. It's another area. Then I can find a single tank where I have 800 megawatt hour. 8 hour by 50, 400 megawatt hour. And in this is the case, in the solar system, I have two fields of mirrors. One for daytime, which I run my power plant, where now already all mini solar power plants are dispatchable. They work 24 hours. One for day operation and the other one to charge my tank, and then I have it for night operation. So this is another area of storage. So I am trying to diversify the portfolio, what type of energy, wind and solar or bio, or hydro if you like. And then in the system, I have air conditioning, and I have water heating, and then I have water desalination, and then I have water pumping. Many farmers need to work for water pumping. I don't like to follow the electrical track. I pump when I have my solar, and having the gravitational power, and have my tank on the level, because in many places water is 1,000 meters deep. And this is a huge problem. And it's very well known, the reputation of Indian pumps, but not with solar and with wind. This should be combined, this one. And then desalination. Many desalination systems are O system. All the Gulf are running in cogeneration power plant, and then you have your, give me 5 kilowatt hour, I desalinate water for you. If it is 40,000 parts per million, like in the Indian Ocean and the Red Sea and so on, or it is brackish, then I need energy, give me 5 kilowatt hour. This 5 kilowatt hour is not available all the time because renewables are intermittent and modular. Intermittent, that sometimes they don't have wind, by night they don't have sun. Then I should make use of the beauty of intermittency. When there is this energy, when I have in winter some wind, then I run my desalination system and I store water in a tank. And then I can enjoy drinking water like in summer from my winter wind. And there is no rate of self-discharge in this water tank, not like batteries. You don't indicate the charge. So actually we have a system or a matrix of different components. In addition to the beauty we have heard these 2 days on the batteries and the combinations and inverters and grid integration and the high penetration, we have also in the energy conversion structure, we still have water to pump, we still have water to desalinate, we still have an air conditioning without electricity, without vapor compression, and then I'd like to have a shower and my dishwasher is running without electrical heater. These are different scenarios, and in my system I have my solar and wind and bio. And then I come to the point of optimization of the energy mix. There are many computer models on how to optimize where you put your system, where are the people, demography. People are increasing, roads and the electrical grids, and the state of the art of technology and the state of the art of pricing. Now we are confronting a sharp drop in different items, like what we are facing in PV, where it produces 80 giga last year and the load was 40 giga. Then we got the drop, and the tenders have shown $6 or $5 cent per kilowatt hour, which there is no utility can compete with these prices. And these are decarbonized output. Then with all of these changes should be dynamic in an optimization model, and even the technology of storage. Which technology? The 10 technology has been built, but they are progressing and there are changes and there is dynamics and there is sizes for power and the energy and time, and then there are prices. All of these are dynamic, so optimization should be done in every stage to park on a solution, how to integrate renewables to our system, not to our grid. Our life is grids, and in some cases I am one for the people asking for no grid, 100% renewable. India government is asking for 100 smart cities. So let us look for an holistic approach, being far from this application, and try to have an optimum zero carbon community, and to take care of the beauty of renewable, to get green jobs, so that our boys and the university graduates get jobs. This is the point we would like to push. Then we should have an educational system or program for energy storage, what are the techniques to educate our people, to run the maintenance, so that without local capacity building, local industry, and well-educated national in the field of energy storage, then we can guarantee continuous progress. And I'll stop at that. Thank you.
to actually get the most out of renewables. So now let me give you some of my thoughts on this before we do the question and answers. There's been a lot of discussion. So one of the things that's I think going to be the focus in the future will be distributed generation resources, which is there to a large extent in Germany, rooftop solar PV, but which is just started in India. There are just about 6 or 7 states which have announced policies of net metering. Some of the states have announced solar policies, rooftop solar policies, but about 6 states have announced policies in rooftop solar PV. So I think what this is going to do is not only to generate at the point of consumption, but therefore what will happen is that it will not require the augmenting of the distribution system in the cities, which is already constrained. So it may in fact decongest sometimes. So this is the requirement, I think, because cities, there's a lot of problem in getting land, building new transmission lines. So I'm sure people in Bombay and Delhi will know that it's very difficult to augment the distribution system. So this is one of the things which should be focused on. The MNRE is got a huge target. They've got a lot of things up their sleeves. So there's a huge target of solar. Not solar PV, but solar energy in general, and not necessarily rooftop solar, but I think a lot of it should be from rooftop solar. That would help decongest the system, use it at the point of consumption, and you only have the net variation coming onto the grid. So you may require actually a little bit less of storage if you do it like that, if you use it at the point of consumption. And as many people pointed out, the unused batteries which are there in the UPS of computers, which is a huge amount in India. Later these can be harnessed so that you can use this, because that is one of the ideas which is being floated in the UK of using batteries which are connected to domestic computers to use the storage capacity of these. So it's something like a distributed storage which is there. That would reduce the requirement of storage. The other thing that would that's really required and would be very effective would be demand response rather than have storage. Demand response is a very effective way of balancing variable generation like solar and wind, and it is being used in the US for a number of years, 7 to 8 years or even more in certain states. But it's not being used in India. And in India, if you give an incentive to somebody to reduce load. Now, actually, there's a pilot scheme in Mumbai where people are willingly reducing their consumption and getting an incentive for it. So, Mumbai Airport is one such consumer, and there are many others. This is done through an aggregator. In fact, it's done through customized energy solutions. Which is organized this conference, and it is an automated demand response pilot project has also been sanctioned in Mumbai. It's not yet taken off because there were some issues on the protocol, because the resort where it was being implemented, what they said was that they should have the ultimate freedom to choose if they want the load should be shared, whereas the protocol in the software was that the control was from the distribution company end. Anyway, I think that was proposed to be sorted out, and that would take place, I think. Then, yes, as Manish said, that what is required now, if you have more and more of renewables, is planning this transmission system in advance, or actually implementing it in advance, because solar plants and renewables get set up within a very short time, maybe 6 months to 1 year. So if these plants come up very quickly, then we won't have the facilities, and if you don't have the facilities ready, it will be a problem. So this is one area where we need to work on and work in a coordinated way. balancing over a larger area, yes, that's one of the things that should be done. If you restrict it to say a state like Tamil Nadu, which is wind rich, then the full wind cannot be utilized. So many times it is reduced, the generation is reduced because there is at the boundary you have this deviation settlement mechanism. So what needs to be done is formulate a new mechanism to see that the variation gets spread out or balanced over a larger area, like it's being done in Germany for the 4 distribution companies, where the variation is spread out over the entire country, the 4 distribution companies, and they had a problem where this variation was flowing into the neighboring countries, and the neighboring country objected to that because it was destabilizing their grid. So they had to use phase shifters to stop the variation going into that neighboring country. We got to have things like this, which would phase shifters, which would divert the flow from areas where you don't want the power to flow to areas where it should flow. So these are all modern technologies which should be used and for optimum utilization of renewables. What would have to be worked out would be the commercial mechanism for such a case, because you will have to have a different commercial mechanism if you want to balance over a larger area between 2 different or 3 different control areas. Thermal storage is, as he said, is very, whenever the wind comes or whenever the solar power is there, you use it either for heating or for cooling. You generate ice cubes and that water. So I think Tata Power Distribution Company has won an award there for that project on thermal storage in India, which is, I think there are lots of, if one thinks of it, that there are many ways in which things can be optimized. And about DC generation, what is also being done or planned is that most of solar PV as well as wind generate DC and gets converted to AC and goes into the grid. Why not have DC appliances, or there are already some solid state devices are all DC consuming devices. So you don't convert from AC to DC, DC to AC back to DC. Convert, use direct DC. Or in some, and also certain appliances, there's actually a IEEE standard which is being conceived for low voltage DC, which is headquartered in Bangalore. I mean, Bangalore, they're doing a lot of work in that for IEEE. So if you use that, then you don't need to, again, you save losses for conversion losses from DC to AC and back from AC to DC. Yeah.
Every electrical power station in Palo Alto, now they are producing the equipment with its energy storage. Your refrigerator at home can run for many hours because it has built-in energy storage system. And shortly I heard from Stanford, the new generation of photovoltaic systems are connected to batteries. Then there is no connection now and DC and inverters. I think in Stanford there is already a photovoltaic system and attached to it a battery, and the air is coming on and out to charge the battery and discharging, and the photovoltaic system does not have a flat plate shape, but they have like cones, and they are using nanotechnology. So now there is a tremendous stride in science. Efficiency is increasing, multi-junction, 3 or 4 junction, efficiency are approaching 40%, and then we have a new generation of batteries attached to photovoltaic cells. So now it is one unit. I knew about the photovoltaic system was built in battery outside and the inverter, but the new generation has been released, and we can read on that there are already batteries attached to photovoltaic system, and the PV panel are not covered with glass because air is exchanging and charging and discharging for the battery. So energy collection and the energy storage are one unit. So research labs around the world are coming up with new, very innovative solutions, changing everything. Could we mean that we have photovoltaic floating on receiver and the energy storage, because they have graphite on the focal point of a central tower. And material laboratories around the world are adding something and a lot of innovation. So perhaps before we come to 2015, there is many revolutions and many prices are dropping. Who can imagine that the price of electricity and PV systems are dropping in such case that it is cost effective, grid parity, no fossil fuel running power plant can compete with the present PV prices, and they are on the same side.
So, as he said, the battery prices also coming down. We came to know yesterday the prices were as low as 11 rupees, and it's expected to drop to 8 or even more and lesser than that per unit. If you take it per unit. Then about standards and regulations for storage devices and for microgrids. Yes, these are required because microgrids should come up in isolated places, and as the grid expands and reaches these microgrids, we must have standards for interconnection of these microgrids to the main grid, which is there in certain places but not in all places. So we may be coming up with these standards, the CA may be coming up with these standards in India for connection of microgrids, because microgrids is always beneficial from security of energy security of that particular area. But local, if the generation is at local level, even if you have a storm or uprooting of towers, that local generation would still be able to cater to the local requirements. As places like hospitals and large complexes should have their microgrids. So you must have standards for that. Also standards for storage devices. Yes, these are things which need to come up, because when these get integrated into the whole grid, these standards are needed to see overall grid security. I think I'll conclude with that. Thank you. And the question and answers or whatever.
Thank you all the speakers. Directly, as a token of appreciation, I would like to give away certain gifts. For that, I would like to call up Mr. Stephen Fernandes, who would do the honors for the same. Can we please have the gifts? Professor Dalal Osman. Mr. Pankaj Batra, Mr. Manish Tiwari, Mr. Madhusudan Khemka, and Mr. Manu Karan. So we'll take a quick 15-minute break, tea break, and after that we'll resume the discussion on Make in India. I would request all of you to please be on time, as we are already running late. So please be here in the next 15 minutes so that we can start.